We're here in Silicon Valley, not that far as it happens from where Tesla's Fremont facility is located. But we're not here to talk about Tesla today. We're here to talk about Lucid and its just released Lucid Air sedan. When I say just released, I mean we've just had the production launch of the Lucid Air. And by now, you know a whole lot about the car, like its price, its range per charge, 517 miles. You know that it's got 19.2 kilowatts of AC onboard charging capability, as well as vehicle to grid straight out of the factory. You'll know that it will rapid charge to 300 kilowatt power levels, and you'll know a whole lot more. But today, I'm going to be talking to two of the people behind the car from both the design and the engineering point of view. And because we are in Silicon Valley and COVID is still very much ravaging the area, we're following very strict protocols. Only one person, the person in front of the camera, has a mask off when they are on camera, and everybody else has a mask on. So like the Rolls-Royce video we did a couple of weeks ago, this is going to be one of those videos where you don't see a whole lot of me. So let's go inside and take a look at the Lucid Air.
I'm Peter Rawlinson, I'm CEO and CTO of Lucid Motors. Well, I joined the company with a clear vision to take the electric car to the next level, and a relatively clear vision as to this new space concept that we've designed the car around, but a less certain roadmap to create the astonishing efficiency that we've arrived at today. And that's been quite a long and tortuous journey.
My name is Derek Jenkins, and I'm the Vice President of Design here at Lucid Motors. The Lucid Air project is really unique and like no other that I've had a chance to work on. We had really truly a clean sheet of paper to start with. We're in a unique time for the automobile and the change that's coming with electrification and technology. So it was a real honor to kind of be able to start fresh, really focus on the design of the vehicle, the proportions of the car, the efficiency through aerodynamics, and of course, bringing all these technologies together in one amazing vehicle and platform was really, really exciting.
A few years ago, we started off with IGBT technology and switching for the inverters, 400 volts, triaxial transmission system, a battery pack which we felt would be needed to be maybe 130 kilowatt hours to achieve what seemed then a relatively ambitious range of over 400 miles. And now we've been able to reduce the battery pack, focus on efficiency, up the voltage to well over 900 volts, achieve over 300 kilowatts fast charging, reduce battery pack size to 113 kilowatt hours, achieve an EPA estimated range of 517 miles through a whole range of incremental improvements. And part of that has been due to our increasing knowledge of our battery pack technology, and we've been able to leverage all the expertise that we've gained through 2 seasons of Formula E racing, where we supply the entire Formula E field. The company was known as Ativa, and we switched to a more palatable name. We've rebranded as Lucid. We've kept Ativa on as our sort of technological wing, our tech division, and we'll probably use that for tech products in the future. But all the Formula E packs were designed, developed, and created here at Lucid. They're actually made in this very building out back. And we have a revolutionary pack architecture which more than doubled the capacity of the pack. And it's an interesting sort of historical note that the very raison d'etre of Formula E was to exemplify the true potential of electrification. It really proved the limitations for the first few seasons, where drivers had to jump out of one car and have this unearthly spectacle of them jumping into another because the first pack had run out of electrons. We changed all that, and we feel that that's for the benefit of the sport. We have a clean, full race distance with one charge now with our Ativa battery packs.
Upon first glance, of course, the Lucid Air is a sedan format, and so there's a certain familiarity to that. But upon a closer look, you'll see that the way the vehicle is laid out, the way the spaces are broken down in the vehicle, is completely different than an internal combustion motor. Through the miniaturization of electrification components, we've been able to bring the size of those components down really small. It's totally different from internal combustion, and give that space back to the occupant area, back to storage in the front and rear of the vehicle, and really redefine the kind of space and freedom you'd expect with a certain size vehicle. So that's the first thing. The second thing is, as a result, the outside of the car has gotten more compact as opposed to the large space on the inside. That's important because it allows us to make the car lighter, lower, narrower, and ultimately more aerodynamic. So you end up with this really unique paradigm of larger on the inside, more compact on the outside. The approach to Lucid Air interior design was one of more minimalism. We wanted a very clean, open look, an airy look, but a sophisticated look. And that meant key materials, metals, wood, leather, or synthetic leather, depending on your choice, to bring a level of sophistication. But opulence is not a term that we use with Lucid. So it had to be more of a minimalist sophistication. And I think that makes it unique in the class. I also think that luxury is evolving and changing. Luxury is more about sophistication and experience and less about showing off. And I think that makes Lucid Air really a pioneer in the luxury segment. On the inside of the vehicle, much like the name of the car, Air, we wanted this feeling of space, openness, airiness. So the form language of the car was about minimizing the volumes, making the instrument panel as narrow and slim as possible, making the door panels as contoured to give this feeling of space. The other big factor is the screens. Rather than having these large prismatic boxy screens, we went for a more elegant, floating, curved display across the top of the instrument panel. That again gives this feeling of airiness, openness, and it's ergonomically contoured for perfect visibility and perfect ergonomic reach for the driver and also for the passenger through the center console. So we went for a kind of sophistication and elegance and ease of use over size or quantity of screens, and that makes Lucid Air interior very unique.
There's a huge amount of learning, and as a beautiful circle actually, the expertise we had from under the learning from our alpha phase of Lucid Air, we used that to steer us towards the design of the Formula E. But clearly those 2 seasons of racing, we've accrued so much information, so much data. We have data from all 24 cars on the grid and deep data. And it's very much a software play, as much as software expertise as hardware. We're as much a software company as a hardware company. All that expertise has gone into steering and developing the design of pack for Lucid Air that is going into production. So truly we have a race-proven battery pack. When I say race-proven pack, it's no lie. There is a direct relationship. The core DNA of the Lucid Air pack is a direct cousin of that used for Formula E. Now, regarding the voltage, that's a happy coincidence. We looked at all the data. What voltage should we run at? What are the pros and cons? Should we go to silicon carbide MOSFET switching technology? And I took the decision that for real world efficiency, there's a magic combination. Combine the silicon carbide tech with ultra high voltage for efficiency. So that's just happenstance. But the core technology within our pack, and particularly the low resistance of the pack itself, that's been derived directly from our expertise in Formula E. We have a unique pack architecture which is designed in-house, and I believe it's super low resistance. It's been one of the facets by which we've increased efficiency by reducing I squared R losses, the current squared times resistance losses in the pack. Now, in the pack itself, you can only address the R, the resistance, so that's what we've done. Strangely, you can influence the I squared, because if you've got a more efficient motor for a given power, you're drawing less current, and that improves the I squared R losses. So you actually get less heat built up in the pack, and less heat to therefore disperse, and therefore smaller radiators, by having a more efficient motor inverter in the first place. So we've got over 90 kilowatts per litre for our inverter. To the best of my knowledge, no one else is even close to that. It's helped by the whole package, the whole architecture, just the film capacitors that we're using, the array of film caps, are pretty small. It's just the elegance of the cooling system. We've developed a unique cooling system, water glycol system, hand in glove with the way we use those MOSFETs. And then there's the 900 volts. And then there's good old-fashioned, elegant, three-dimensional mechanical engineering. I'm particularly proud of the way the three-phase connections just plug direct into the motor. You haven't seen that. That's deep in the heart of the system. Just the sheer elegance of the busbar connection, because then that reduces I²R losses, it reduces the amount of copper we're using, it reduces the weight, and it leads to compactness. So again, it's big picture thinking. There's no one thing. It's just millimeters here and there, amps here and there, ohms here and there. It's capacitance. It's the big picture.
The front of the car has two primary technologies that give it its aesthetic. As you know, aerodynamics is a big priority for us, so the cooling of the front of the car is unique to that end. But the other big factor is our lighting technology. We have something we call intelligent micro lens array, and that's a unique micro lens, almost like an insect eye, that takes hundreds of tiny lenses to control and manipulate the light precisely where it needs to go on the road ahead for the driver's view. Also takes into consideration glare for oncoming traffic. That's also unique because it's very energy efficient. We use LEDs as the primary light source, but because of the lens efficiency, we can reduce the power consumption of the LED, ultimately impacting the overall system efficiency of Lucid Air. And lastly, the lighting aperture or size of the light is incredibly compact. We're around 24 millimeters, approximately an inch high, which will be the slimmest lighting aperture on the market when we launch. On the front of the car, we have several unique cooling openings. We've tried to minimize them, bring them down as slim and as efficient as possible. Even the lighting has an opening to let airflow come in at the top of the headlight, cool the light itself, and then exit out the hood. So it's a really cool feature that benefits both the aesthetic of the car, but also the cooling of the lights and aerodynamic quality. In addition, our primary intake that cools battery, inverter, motor is a very slim opening. We have a shutter system at speed, and that flows into a vortex induction that spins up the airflow, accelerates that through vortex, and then distributes that air over two radiators in front of the wheels. Very efficient, ultimately benefiting us from a thermal standpoint as well as an aerodynamic standpoint. The rear of the car is really such an important design feature. And I think what sets that up, first of all, is the aluminum canopy. You know, this canopy was really inspired by kind of aircraft and this feeling of like a jet. And so we wanted to keep this kind of naked aluminum quality on the outside of the car. And gives you this very strong pillar at the rear. And then we have this wrap around rear glass. And then that sets up this incredible rear hatch cargo area, or the trunk. And you end up with really wide loading and just creates a completely different look. And all of that is topped off by this seamless one-piece taillight that goes from side to side and makes it definitely unique in the sedan class.
I passionately believe that the impact we can have upon the environment and people's lives are enhanced by this. And really, this bidirectionality of the charger and the Wunderbox and the sheer capacity of 19.2 kilowatts gives it so much more functionality. As a lifestyle tool, you can power your vacation property, your chalet by the lake, your hunting lodge. You can go off grid and use that for the weekend. Or if there's a power outage, with disconnecting your home transmission system, you can power your home from the car. You could charge another car to car. There's countless opportunities here. So personal level, it's very valuable. On a business level, there's a real opportunity in saving peak shaving costs. Here at Lucid, we pay a considerable sum of money every year for not just the amount of electricity the building uses as a business, but the peak usages of peak periods throughout the week. Now, in a year's time, when we have an array of lucky owners of Lucid Airs outside, we'll have them all charged in. We'll offer free charging here at the company, but there's a quid pro quo that their cars will then complement the input of electricity from the grid to shave those peaks. And we can save as a business the peak shaving costs by having Lucid Airs working V to G, in this case V to building. So there's another value. And then the ultimate value of this is as a nation state, reducing greenhouse gas emissions over a 24-hour period, over that cycle, of better balancing the draw upon a grid by using tens and tens of thousands of Lucid Airs working in harmony with big data to balance the grid. So we don't get this unhappy asymmetry in the use of certain power stations sleeping when the nation sleeps and having to stoke up when everyone switches their kettle on to make their morning coffee. In Dinorwig in North Wales, there's a power station which has got a lake on the hill and there's a lake low down. And at the Dinorwig hydroelectric power station, it draws electricity from the grid to pump the water back up the hill when there's a surplus of energy or power available on the grid in the UK. There's a sort of intellectual analogy here. Instead of the water on the hill and the potential energy of that water on the hill, think of the potential electrical energy of tens of thousands of Lucid Airs. They can be that water on the hill, absorbing surplus energy from the grid when necessary and giving back when appropriate to balance over a 24-hour period.
One of the things I'm really excited about is the Lucid Air, from a physical footprint size and overall vehicle size, is mid-size in length and width and in height. So think E-Class Mercedes, Audi A6, but on the inside, we've got full S-Class or full-size luxury space on the inside. And this is a true achievement because the size of vehicles is typically associated with internal combustion motor and passenger space motor. So we've really broken that sizing paradigm, and I think that's really unique. Another design feature that I'm super excited about and kind of obsessed about is our wheel design. The wheels, are an important kind of visual statement for any car. It kind of sets up the proportion of the car, the stance of the car. But in our case, we had two primary other functional goals. The first is aerodynamics. So we had to create a very aesthetically pleasing wheel that also had to have a very flush aerodynamic efficiency to it that left enough cooling for the air to cool the brakes and be excel outside, but still keep the flow down the side of the vehicle very, very smooth and controlled, as well as keep the wheels very lightweight. So we had a very unique set of parameters there. And it's not just one wheel design. We have 5 wheel designs that will come to market throughout next year. And each one of them follows those core design and engineering principles.
I wanted it to be understated and tastefully understated. And I think that there's an interesting analogy here. It's in this little device. I mean, there was a time when people would walk around in the city of London, maybe I'm showing my age, the 1980s, and it was cool to have a huge device here. And I think the new cool in cars is going to be this elegant understatement, this subtle, smaller car. This car, Lucid Air, is smaller than a Porsche Taycan on the outside. Nobody believes it because they see pictures of this expensive interior space, which is more Maybach-esque in its size, and think this is a humongous car. It's not. It's shorter and narrower than a Taycan. It's shorter and narrower than a Tesla Model S, and it's more aerodynamic than either of those cars. So this is about subtle refinement. It's about discreet taste, and it's for a discerning clientele.
Obviously, we've put a lot of effort into this, and Lucid Air is not something where we've done clinics and a ton of marketing, data-driven. We've done the vehicle that follows great principles of design, great principles of engineering, performance, efficiency, and wrapped it into something that we feel we're very proud of. It's a real achievement, and it's something that, having done this a while, I have a pretty strong gut feeling that it will be received really well, and I think people will be blown away by its capabilities and its features and the functionality of the vehicle. The whole goal of this is to accelerate electrification in the marketplace, blow people's minds in the process, and make a successful product.
I'm not here to make a rich person's toy in low volume. The real value of the technology that we're developing today is to influence the mainstream cars of tomorrow. And we're doing that in 2 ways. First of all, we're developing the most advanced technology to date in the EV space. And the true metric of that is efficiency, not range per se, because we can add dumb range by just adding number of batteries, and I'm not interested in doing that. We could have a 150 kilowatt hour pack and achieve 500 miles, and that's not a smart thing to do, and I would be ashamed of doing that. What drives me is creating efficiency. And you say, well, what's the relevance of that? Well, the relevance of that is, first of all, to exercise today's demon, which is range anxiety, and replace that demon with an angel, which is range confidence. But the way we exercise range anxiety today is carrying the range on the car. What I want to do is portray this efficiency, the true value of efficiency, not necessarily in range for a car today like Lucid Air, but cost effectiveness for smaller cars in the future. Because what we have here is we have an efficiency quantum leap above anyone else in the market, in excess of 15%. That's equivalent to, directly equivalent to, a 15% breakthrough in battery costs, because it means you can have 15% less cells to do the same thing. But if you have 15% less cells, it's even better because you can make the car lighter, the rest of the car and the brakes. So it's actually better than a 15% decrease in cost of the battery. So this is akin to a very significant quantum leap in battery technology. But we've approached it holistically, not just looking at the batteries. But there's a whole another dimension to this that we're addressing, and that is design for mass producibility. If you look at even the market leader today, their powertrain systems are not truly optimized for design for mass production. That's my opinion. And if you look at the way, back to back, our designs versus the market leader, our designs are cheaper to make and much more consistent in their outcome. They're much more computer manufacturable. And this means that we can have a significant cost down in our technology. And that can then cascade to much more affordable cars in the future. And we've talked about the value of this efficiency. You know, Lucid Air is achieving what? Over 4 miles per kilowatt hour. Not on a WLTP cycle, not NEDC, we're talking at EPA multi-cycle. A smaller car, more Golf-like, my vision would be to achieve 5 miles per kilowatt hour. With fast charging stations everywhere, that would be a range attenuator. Why couldn't we live with a 150-mile range on the car rather than have the range anxiety antidote of today, which is to carry the range on the car? Let's use the antidote of fast charging stations everywhere. Carry 150-mile range on the car, 5 miles per kilowatt hour. That's a 30 kilowatt hour pack. Get cells to $100 per kilowatt hour. That's $3,000 of cells, $4,000 at pack level. That's going to lead to the $22,000 EV of the future. And the technology that Lucid's developing today is a core enabler for that to happen. That's what really excites me, making millions of cars so that can really make a difference to the environment.
Having sat inside a pre-production Lucid Air today, well, I can say I'm surprised. I expected a very luxury, high-end electric car that was maybe a little over the top in terms of the fit and the finish and the trim. And by that, I mean ostentatious. Think Byton, think Faraday Future. I expected Lucid to be like those companies. But to my great pleasure, it is none of those things. It's not as tech-centric as Tesla, where when you get behind the wheel of a Tesla, all you see is those giant touchscreen displays. The Lucid Air is more subtle, more refined. It's got that very thin dashboard in terms of the thickness of the display, beautifully curved. The interior is very carefully thought out. And while the interior is very, very high-end, very high quality, the car itself doesn't feel ostentatious. It's not showy for being showy's sake. It's not like the Porsche Taycan where you get behind the wheel and know that you are driving a really expensive car. No, the Lucid Air is more subtle than that. It's not focused on the car's sticker price or maybe even the end market. It's understated, but in a very, very beautifully done way. It's a car that you will want to drive on a daily basis. That's if you have the money. And that's really where we're going with this car. While this is a high-end, high-performance, high-ticket car, Peter Rawlinson and the rest of the team at Lucid want to trickle this technology down. Not necessarily all of the bells and whistles of this car, but rather the energy efficiency, the improvements in inverter and battery cell chemistries down into vehicles that have very small battery capacities, but an ability to charge very quickly on the motorway or the freeway. Cars that have very low sticker prices. And I, for one, am very excited to see what that future looks like should Lucid make it happen. Thanks for watching. Thanks to everybody who's scrolling by on my right. You guys make trips like this possible. Thanks ever so much to Erin, who has joined me here in the Bay Area today. It's been a pretty stressful trip. We've had to self-isolate before going on the trip to make sure we didn't give each other COVID. We've had to take all of our food with us, and we've had to really minimize any contact with anybody outside of the car or the team. But we've made it happen, and hopefully we'll be able to do more videos like this in the future. Don't forget you can support us by using one of the links below, and I'll be back with more great content for you all to enjoy very soon. Keep evolving.